Foundations of Amateur Radio. In the past, I've talked about the standing wave ratio, the SWR, and how it describes some of the characteristics of your antenna system. I say system because it's not just the antenna. It's the connection between your radio and the antenna as well. The coaxial feed line, their length, and how you've connected your antenna all feature in the performance of the entire kit and caboodle. As an aside, that's why measuring an antenna with an SWR meter at the bottom of the antenna while you're bolting it to the top of your mast is likely to give you a different result when compared with the measurement performed at the radio. During the week, I was asked about how cutting an antenna changes the SWR. The question included a quote from the ARRL single band dipoles page which states, "If you see that the SWR is getting lower as you move lower in frequency, your antenna is too long. Trim a couple of inches from each end and try again." The person asking the question, Phil, wanted to know why he was seeing a different behavior. I've seen the same myself, and until I had the benefit of an antenna analyzer, it also made little sense to me. The reason it makes little sense becomes clear once you realize what assumptions you're working under. When you look for antennas online or when you buy one, often it comes with a lovely SWR graph. You'll see frequencies on the horizontal axis and SWR on the vertical axis. You'll likely see a lovely, mostly horizontal line with a dip downward at the frequency where you want to use this antenna. The assumption you will almost automatically make, I know I did for years, was that outside the graph the line continues on its merry way in both directions. That means that you're assuming that the SWR comes down in one place and the rest of the time it's high. If wishing made it so. With the benefit of an antenna analyzer, you can graph the whole HF spectrum, and depending on the hardware, you might even be able to see VHF and UHF or higher. One thing you'll immediately see is that the SWR is all over the place. It's up and down, crazy lines across the whole spectrum. You'll find enormous highs and some very interesting lows along the way. It's one reason why I can use an antenna intended for the 10 meter band on the 2 meter band. When you're making an antenna, like a single band dipole, you might find yourself in a position where your antenna SWR is going up and down like a yo-yo around the frequency where you're wanting to be. The higher the frequency, the more likely that your trimming ends you in a different dip or a different high outside the one that you're actually looking for. One other comment. The ARRL quotes, which is talking about HF dipoles, states that you should remove a couple of inches from each end. Let's take that literally, 2 inches from each end. That's 4 inches in total. Let's call it 10 centimeters between friends. If you're trimming a dipole for 160 meters, you'll change the frequency by just over 1 kilohertz. But if you're doing this on 6 meters, then the same trimming will change the frequency by nearly 1 megahertz. And if you use that HF recommendation for 2 meters, the change is almost 6 megahertz. So trimming a couple of inches, as the ARRL suggests, will work for some dipoles on some frequencies, but might get you completely crazy results for other frequencies. Now you know, the SWR isn't high across everything except where you care. It's all over the place, and sometimes that helps, and sometimes it doesn't. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.